Hello guys, so now I'll be explaining the chapter 3 CQD questions. We have 1, 2, 3, and 4, 6, 9, 10, and 12. Not everything is included, so I'm just gonna solve the included ones. So first, we're gonna start. Calculate the concentration of H plus and the concentration of OH minus in a 0.010 molarity solution of LiOH. LiOH releases what? OH minus ions. So that means this is directly what? The concentration of OH minus. So we already found concentration of OH minus, which is 0.010 molarity. So now, very simply, to find the concentration of H plus, we know that the equation is that the constant of water is equal to the concentration of H, I don't know what happened, concentration of H plus times the concentration of OH minus. Concentration of water is 1 times 10 to the power of negative 14, which is equal to concentration of H plus that we need to find times the concentration of OH minus, which is 0.01. Bring this to the other side. Concentration of H plus is equal to 1 times 10 to the negative 14 divided by the concentration of OH minus, which is this. So to put it on the calculator, we are then gonna get that the concentration of H plus is 1 times 10 to the negative 12. Then we move on to question number 2. Consider the following. We have this table over here. Let's name it. Al2O3, if you remember, it is ampho. I believe it's ampho. You spell it like this, amphoteric, okay? Calcium oxide is a metal plus oxide, so it is basic. Carbon dioxide is a non-metal plus oxide, so it is acidic. Okay? Carbon monoxide is a neutral. MgO is a metal with an oxide, so it is also basic. And then finally, SO2 is a non-metal plus an oxide, so it is acidic. Alright? So now they're telling us which of the following can react with hydrochloric acid. So they can react with an acid, but not with a base. To react with an acid, but not with a base, it has to be basic. So the only two that are basic are CaO and MgO. In the second one, they're asking us it can react with NaOH, so a base. It can react with it, but it cannot react with an acid. So if it can react with a base and not with an acid, then it has to be acidic. So what are the two acidic? We have CO2 and SO2. Now, it cannot react with both hydrochloric and aqueous, sodium hydroxide, so it cannot react neither with an acid nor with a base. So that means it's neutral, and the only neutral is CO. And finally, it can react with either this or this, so both an acid and a base. So we say it's amphoteric, so it is Al2O3. So now we go down, and number 3, they want us to fill in the table as acidic, basic, neutral, or amphoteric. First of all, we have a metal plus an oxide, so this is basic. Non-metal plus an oxide, this is acidic. Okay, then we have copper plus an oxide, this is a metal plus an oxide, so it's basic. N2O, you have to memorize that it is neutral. CO is as well neutral. ZNO is amphoteric. Okay, SO2 is a non-metal with an oxide, so it is acidic. Al2O3 is amphoteric, and then finally CaO is a metal with an oxide, so it is then basic. Okay, now number 4. So they're asking us which of the following elements is most likely to form an acidic oxide. Acidic oxide means non metal plus oxide. All right, so that means for sure it's not gonna be A or B because A and B are metals, okay? It's definitely not gonna be D. Why? Because D is a noble gas and noble gases do not react with anything. So that leaves us with C. So C is the answer of C only. So we don't have 5. 5 is 2 pages. Now we have 6. Okay? If the burette was filled with dilute hydrochloric acid and the solution, if the burette was filled with dilute hydrochloric acid, so we have an acid, and the solution was slowly added to a conical flask containing dilute sodium hydroxide solution. So we have what? We have also NaOH, which is a base. What will the color change be if the following indicators are added? So what we're doing is that we're putting acid into the base. So what's happening is that it's changing from a base to an acid. So base in litmus is blue to acid, which is red. Methyl orange, base is yellow, and for the acid it is red. And then thymolphtaline, in the base it is blue, however in the acid it has no color. We don't have 7, we don't have 8, but we have 9. They told us calculate the concentration of H plus and OH minus in a 0.01 molarity solution of HCl. HCl releases H plus ion, so we have 0.01 molarity. This is already the concentration of H plus ions. We found it. Now the concentration of OH minus ions is 1 times 10 to the negative 14, okay, divided by 0.01. So if we're gonna do it, it's going to be 1 times 10 to the negative 14 divided by 0.01. We're going to get that the concentration of OH minus, this is minus, my bad, is 1 times 10 to the negative 12. That's part A done. Now part B. They want us to calculate the H plus and OH minus ions in a solution of 0.40 grams of NaOH dissolved in 10 centimeter cubed of solution. If you remember, molarity or concentration, we will say C is equal to the number of moles over the volume. We have the mass in grams. We can divide it by the molar mass of NaOH. So very easily to find the concentration, and we're given the mass, we can do first of all, to find the number of moles, we're going to do the mass divided by the molar mass, so 0.40 divided by the molar mass of NaOH, which I believe is 40. So 0.40 divided by 40 is going to give us 0.01 moles. So now we have the number of moles, 0.01. The volume should always be in decimeter cubed or liters. So to change it, we're gonna divide by 1000. So it's gonna be 10 divided by 1000, which is also 0.01. So now we have the concentration, okay, of NaOH, which is 1 molarity. How? 0.1 divided by 0.1, which is 1 molarity. So NaOH releases Na plus and OH minus. So that means the concentration of OH minus is now 1 molarity. So now easily we can find the concentration of H plus by doing 1 times 10 to the power of 4 minus 14 divided by 1. And so now we get that the concentration of H plus is 1 times 10 to the negative 14. So that's number 9 done. Now we have number 10. They're telling us if the pH of a solution is 5, what is the value of H plus? Very simply, they gave us the pH. So we're going to write the equation as 1 times 10 to the power and we're gonna put the same exact number in the exponent but negative. So 1 times 10 to the power of negative 5. This is the solution, or no, sorry, this is the concentration of H+. Now, since the pH has a solution, since the solution has a pH of 5, then it is acidic. Now, we are left with 12. We just need to define if a solution has a pH of 5, then it's definitely acidic. If it has a pH of 8, it is basic, and then if it has a pH of 7, then it is neutral. I hope you guys enjoyed. Have a wonderful day, and thank you.